Hello, and welcome. My name is Justin Parker, and my teammate is Victor Espinoza. This video is made for the EEL4743L Microprocessor Laboratory. This video will showcase our final project, the USS Sunil. This video will show the product objectives and goals, overview of the hardware, overview of the design code flowchart, and a practical demonstration of the project, the USS Sunil. Let us begin. Product objectives and goals. Design a 1/100 scale version of a sailboat with Autodesk Inventor that will feature a built-in servo. Print the high-resolution 80-micron layer parts. Learn what Freedom Board pins to use. Learn how to use the capacitive touch slider. Learn how to program a servo via the Freedom Board. Learn how to combine and fuse the servo movement with the capacitive touch slider. Assemble the servo, printed parts, and the Freedom Board. Test the USS Sunil until its performance is satisfactory. Overview of hardware and software. For the software, we used Autodesk Inventor to create the boat, the hull, and the sail/shaft. We then used Autodesk Mesh Mixer to add supports to the hull of the boat so that it could be properly 3D printed. Flash Print was then used to prepare the files to be 3D printed. Flash Print imports the STL files from Autodesk Inventor and Mesh Mixer and slices them one layer at a time so that the 3D printer can understand how to go about 3D printing it. Embed.org was used to program the Freedom Board for the USS Sunil. Hardware. The Freedom Board KL25Z board was used. A 6-volt supply was used. For the 6-volt supply, we had 4 AA batteries, which are 1.5 volts, in series connected to each other. The servo was a Tower Pro SG90 servo. We used Hatchbox PLA for the 3D prints. We used black and white, black for the hull and white for the sail. We used a FlashForge 3D printer to print these items. Here is our block diagram of the USS Sunil. The computer provides power to the Freedom Board through the USB cable. The capacitive touch slider, when touched at a certain location on the one-dimensional axis, provides a value to the Freedom Board. That value is then connected through the software to the position of the servo. The servo is connected and powered by a 6-volt supply, and the servo is located in the hull of the USS Sunil. The servo gear at the top of the servo rotates the shaft of the USS Sunil, which it also rotates the sail because the sail is on the shaft. Here is the design code flowchart for the USS Sunil. First, we include the libraries. These libraries are the TSI sensor library for the touchpad, the embed library, and the servo library for the servo. We then initialize the servo object and tell it to use PTE number 20. This is the pin in which the signal is going to be sent from. The touch slider object is then initialized. Then we enter a forever loop. In this forever loop, the touch sensor provides a value when the user places their finger onto the one-dimensional capacitive touch slider. This value is then used to send the servo to a certain position within its 90-degree angle range. Once the finger is removed, the servo position will be held until the finger is placed back on the capacitive touch slider to obtain a new servo position value. Here is a practical demonstration of the USS Sunil.
I'm sailing away.
Here is all of the components that were used in the USS Sunil project, along with the USS Sunil. Thank you for watching our final project entitled the USS Sunil.